Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Today our group want to introduce about exploring the intersection of serverless computing and edge platforms, which is about performance, architecture and future directions. Our group from group 1. So next. This is our group member. First is Muhammad Ashraf bin Muhammad Isham, and then Najam Fakri bin Nordin, and my name is Hairi Alwi bin Yusof. The other group member is Muhammad Harid Syahmi bin Mazlan, and the last one is Muhammad Azman bin Bazli. Introduction about serverless computing. What is serverless computing? Serverless computing enables developers to focus on code, not server management. Utilize stateless, event-driven functions that execute and terminate based on triggers. History about serverless computing and evolution. Serverless computing introduced in 2014 with AWS Lambda, grew in popularity due to resource elasticity, scalability, and cost efficiency. Evolved from SaaS, PaaS, and IaaS models. AWS Lambda simplifies infrastructure management, boosting innovation. So next. So the objective from our group is, the main objective is serverless enables code focus over server maintenance via event-driven functions. Evolving from cloud models, it complements edge computing, improving agility and IoT through FaaS auto-scaling. Research explores architectural implications across layers, evaluating open source framework, overheads, tooling, and cloud-native aspects. Key focus areas include platform development, WebAssembly integration, real-world characterization, technological difficulties, and tracing serverless origins for comprehensive architectural understanding and optimization. So the next present I will give to my group member. Thank you.
Okay, that is a framework of Article 1. We can look about the controller. You can see UI, API gateway, clock event source, and worker. So the master in around controller entertainment, log forwarded, console, and registration, and also have an execution engine about the worker, registration, and log forwarded. So that is a framework of Article 1. So I will explain about Article 1. So it's a serverless platform architecture. Okay, so the Article 1 problem statement, we can see about the hybrid edge cloud architecture, suffer latency from UI, API gateway, cloud event, source, and controller interaction causing performance for net solution. So we can see about the clock event, source, and controller, as well the communication within execution engine. It can lead to delay that affect the overall system performance is the problem statement. So the solution is optimize communication by reducing hooks using edge caching, local processing, and minimize the data transfer to improve the performance. So that is the solution for the Article 1. The next, we can see about the framework of Article 2. So you can see about the system coordination, system orchestration, and capsule and visualization. We can see about the API gateway, data cache, query, and storage. It's about the server and also kernel and hypervisor and container engine. So that is the framework of Article 2. I will explain about the framework. So the second article is the layers serverless architecture. Okay, the problem statement is managing resource in multi-layer serverless architecture, including load balancer and controller instance pools, is a complex that can lead to inefficiency. So the problem statement is about the resource management and optimization in multi-layer serverless architecture. Okay. Now we can see about the solution from the problem statement. The solution is to use machine learning for dynamic resource allocation, optimizing container and VM instance pools based on demand prediction. So The solution is to use a machine learning algorithm to predict and dynamically allocate resource based on current demand. We can see about the dynamic resource allocation lah.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami bin Mazlan and my matric number is 074974. Now I will present about framework of article number 3. Okay, first we got here is a cloud data center, serverless platform, and lastly we got a edge network. For this article, the problem is the architecture aims to solve is enabling highly scalable and event-driven computing capabilities while abstracting away the underlying infrastructure management complexities. And for the solution is edge network cloud data center. This extends the serverless capabilities to the edge closer to data source and end users, and it compromises edge device capable of running serverless functions for low latency processing. Now we move to the third article, a simplified serverless edge computing paradigm. First we got here is problem statements. This architecture enables scalable, event-driven computing by abstracting infrastructure management through a serverless platform spanning cloud and edge device. And lastly we got solutions. For solution is edge device run serverless functions near data source for low latency processing. That's all from me. Thank you.
Hello, my name is Najwan. Today I will present about the purpose framework, which is the Serverless Edge Computing Framework, SECF. Okay, here multiple edge nodes are connected to the centralized orchestration layer, which control data routing and serverless function execution. Edge nodes enforce security protocols, store and cache data, and carry out computation locally. For performance tracking and optimization, data and operational metrics are sent from edge node to monitoring and analytics layer. The security and compliance layer makes ensuring that standards are followed and the system is secure overall. Next. Okay, here we can see the diagram of the serverless edge computing framework. We can see that there are 3 edge nodes, and under the edge node we can see the serverless functions, data storage or cache, and security modules. Nice. Okay, and then the conclusion and recommendations. And our key finding is serverless frameworks have significant performance implications in edge environments. Architectural consideration and optimization strategies are very crucial. And our recommendation: assessing frameworks like Kubeless, Apache Apovis, OpenFast, and Native for specific use case. Focus on response time, throughput, and deployment ease. And our future research exploring alternatives like WebAssembly for better efficiency and promoting industry collaboration to address the technical challenge. That's all from me. Thank you.
Okay, so we prepared for related study, and for the first study is with the title of Serverless Computing, Economic and Architectural Benefits and Challenges, which focus on economic advantages and architectural constraints of serverless computing. The second study is Edge Computing for IoT, Performance Analysis and Optimization Techniques, which focus on performance optimization in IoT applications using edge computing. And the third study is Open Source Serverless Frameworks, Performance and Scalability in Hybrid Environments, which focus on evaluation of open source frameworks in hybrid cloud edge environments. And the last study, which is study number 4, is WebAssembly and Containers, Implications of serverless computing, which focus on comparing WebAssembly with traditional container-based approaches. Okay. And for references, the key references, number one is serverless computing, economic and architectural benefits and challenges. And second key references is edge computing for IoT, performance analysis and optimization techniques. The third one is open source serverless frameworks, performance and scalability in hybrid environments. Fourth is WebAssembly and containers, implication for serverless computing. And we prepare additional references, which is systematic mapping study of serverless computing and fast profiler, tool for profiling fast platforms. That's all from our group. Thank you very much. See you next time. Thank you.